Hello everyone and welcome yourselves to third part of this video tutorial series on OpenGL 2D game programming in which we're building a simple snake game. And I'm Ratul and this is the Pentamolus project. So let's get started with stuff. So in the last video we worked with the projection matrix, and we have our desired orthographic projection on the screen. So now the next thing we'll do is draw stuff on the screen. So we will need a pretty nice grid on the screen right here, because it is easier to work when you're working with squares, grids, because you can easily work with coordinates. So we are going to make a square for each unit, a square of side 1 unit, so it will be easier for you to work with the coordinates on your screen, and so this will be easier. So let's get started by just adding a new file to a project, because the drawing stuff I prefer to do it in the using a separate file. So you add a new C++ source file to your project, and you can name it whatever you want. I'm going to name it game.cpp, and let's add it, and it should be built for both debug and release. And so this is our new file, game.cpp, and now you will also need a header file for this, and C++ header file. So this is the header file for the game source file, so it will be game.h. and so you don't need to check these boxes, because this is a header file and it is not compiled, and so this comes with a basic setup here. So this will just check if the file has already been included. The content will not be pasted again into the main source file. And so now first let's include the header file into our main file. So because of the declarations for the functions and maybe constants will be contained by the header game.h file, and which also will be used by the game.cpp, and we are going to draw stuff using this, so we also need to include OpenGL stuff. So OpenGL stuff included, and so to draw a grid on the screen will work in an easier way. So a function will be called first, which will initialize the coordinates of the grid that we are going to create. I mean the dimensions of the grid, because this size of 1 unit of the grid is going to be 1 unit on a coordinate system. This will only the dimensions of the grid will be initialized by a function named init grid, which takes 2 coordinates, int x and another integer y, and we need 2 variables here, grid x and grid y. So the value of the x, the dimensions of the grid for this file will be stored here, which will be initialized by this function. So this function needs to be called from our main file. So this function will just initialize the stuff. So initialization. So here we have done the initialization, and now we'll create a new function to draw grid. So this function takes no arguments and returns void, and this will draw the grid. And so let's put the declarations for both of these functions in our game header file, because this will be included in the main file. So 2 functions, initialize the grid, 2 integers as arguments, and the second function, draw grid, no arguments. And now we'll include the game header file into our main file. So we have included this here, and let's also put this in our game.cpp file. We need to include OpenGL. And so this should be the basic setup of both of your files and of this right here. And so now to initialize the grid, you can use your init function. So you can initialize the grid dimensions from this function. So it will be init. Okay, so before we do that, we need it will be better if the dimensions of the screen, the grid inside the screen, are set by some variables here, by some constants here, because then changing them will be easier. So x coordinate, which is columns, and 40 columns and 40 rows. And so we need the same dimensions for the grid as we have for the coordinate in our screen. So we will also initialize the projection using these values. So this will be better. And remember, the x coordinate is columns and y is rows. So now projection, the area of this, the area covered by the screen will be the same area which will be covered by the grid. So basically we have a grid that covers whole of our screen and does not go out of the screen. So we will initialize the grid with the same values, columns and rows. And so grid is initialized, and now the draw grid function will take care of drawing the grid. So now how we draw grid? So basically we need to draw many squares at many points inside our screen. So let's make a different function to draw a single square unit. So we'll call it void unit, and takes two arguments which will specify the place at which the square unit will be drawn. So the square will have a side of 1 unit. And so this will draw a simple square at the point which is supplied to it by the draw grid function. And for now, let's start drawing stuff. So how do you begin drawing? So this is simple. You just need to call the glBegin command, and you need to specify a mode, the drawing mode. Like you can draw many geometric primitives like lines, polygons, triangles. So you need to specify one. So here we are going to use the glLine loop. So what is a line loop? That the vertices you specify are connected and a loop is formed. And the significance of a loop of lines is that the first vertex and last vertex that you have specified will be connected. So a closed figure will be formed, and because the first and the last vertices will be connected. So, and also glEnd when you want to end the drawing your stuff. So now between the commands glBegin and glEnd, you need to draw all of your stuff. So you need to draw a square at this point. So let's keep this point the bottom left corner of the square that we are going to draw, and the square will be of side 1 unit. And so if you need to understand, like, I may demonstrate a bit here. And so let's assume that this point right here, x comma y, is a point supplied to the unit function to draw a square at this point. So we'll consider it as the bottom left point at which the square is to be drawn. And so then we need the next points in this order. If length of 1 unit is this much. So we need points in this order. Second one right here, third one right here, the last one right here. So this one, so this length is 1 unit. So this will be x plus 1 comma y, and so we define these 2 points, and these will be joined because this is a loop of lines. And so the next point should be this, which will be x plus 1 comma y plus 1, and because this distance is also 1 unit because this is a square. So, and the next point which should be joined is this, and so this will be joined when we supply a point which is x comma y plus 1, and these are the first and the last vertices. So these will be joined because we are using a line loop. So in a loop always a closed figure is formed, and so the first and last points are joined. So this will be the work done by the unit function if x and y are the coordinates specified to it. And the next time you specify this point, a square will be drawn this side, and similarly by combination of these squares you can draw a grid on the screen, and you can use loops to draw a lot of squares on the screen. And so for the grid we're going to do this. Now let's know how to supply points and stuff. So first thing you need to worry about is the setting the color in which the lines will be drawn, and also the thickness of the line. So thickness is by default 1.0, and the color is by default white. So for demonstration I'm going to set the defaults again. So line width should be 1.0, and so this is a floating point, and to set the color we use glcolor 3f command, 3 floating points which are the RGB values. And if you don't know about RGB values, you should probably go back to the second part of this video tutorial and watch this, because I explained stuff about RGB and that and how to use these. And so for a white color the intensity of all the colors should be full, which is 1.0. And so now we can draw our line with these values set. And so to draw a line we need to specify the vertices, which is done through GL vertex, and it is a 2D vertex, so 2 floating points will be taken in, will be x and y coordinates. And so these will be first x and y like I just showed you here using the diagram, and we'll specify the vertex, no need to tell them again, just put the values I just made you understand about. And the final one, and so this will be drawn using this. Now we can for just testing it, we can just call unit function from our draw grid function to draw a square at point 20, 20. And so we have not yet called the draw function, draw grid. And so, okay, I'm sorry for this. So it was like this before. And now we need to call the draw grid function from our main file. So we have already initialized the grid with columns and rows. And now to draw grid, the function should be called from the display callback, so that the grid is drawn every time a new frame is displayed. So it will be the grid will be drawn after the color buffer is cleared and before the buffers are swapped. So we'll call this right here. And so the grid will be drawn on every frame. So this function will be called from here, and this unit function will be called, stuff will be drawn, and then it will jump back to this, and the buffers will be swapped, and the grid will be displayed for a frame. And so now let's try and run our program and see if there are any errors. And there aren't any, so we get a square right here as we wanted. And so now for drawing a whole grid, you may consider using the for loops. So I'm going to implement a simple algorithm here. Tx equal to 0, x is less than grid x, because this will be 40 for this, and x will be incremented. And similarly we will nest similar stuff for the y coordinate here. And so now the unit function will be called with the values x and y. So if you're not able to understand this stuff right here, I would recommend you to go back to your C++ tutorials and learn about for loops. And so how this works, it works simple, that for first time the value of x coordinate is 0, and it runs a loop, and inside there is a nested loop for the y coordinate, which is initially 0, and it goes up to the length 1 less than the length, 1 less than the dimension of the grid we need. So it is first x is 0, y is 0, then unit function call with 0, 0, then again this loop runs, and y is 1, so 0, 1, similarly 0, 2 up to 0, 39 right here, and then this loop runs again with value of x equal to 1, and so it goes then 1, 0, 1, 1, and 1, 39 up to this, and then 2, 0, and up to 39, 39, which is at the top of the top right of the window, and it draws a whole grid on the screen, which is of the size of the screen. So, and if we try and run this, we should now get a grid. Yes, we do. And so we have a really nice looking grid on our screen. And one more thing that I want to add in this is that the snake will move around in this area, and the boundary of the grid should be colored red, because this will be the danger area where the snake should not go. And so the edges of the grid should be of a different color, which most likely and most suitably which should be red. And so to do that stuff, like in the unit function, we are initializing the width of the line and color. So at the starting, so we can first check what are the coordinates of the box that is going to be drawn, and set the color and width of the box accordingly. So the boxes at the edges will have a red color and higher thickness than this. So we'll remove this, and we'll implement a logic to test if the box is at the edge. So this will be if x equal to 0, if the x coordinate is 0, or if the y coordinate is 0. So this means if the box is at the left of the screen, and this checks if the box is at the bottom of the screen, or if the box is at the rightmost part of the screen, which will be x is equal to grid x minus 1, because it is never going to be 40, because the first box will be drawn at point x equal to 0, and so the last will be drawn at 1 less than full, that is 39. And similarly y is equal to grid y minus 1, and so line width should be let's keep it 3.0, and intensity of red to full. And if this is not true, we'll keep the box simple. We'll keep the box simple, and the width of the line we will keep 1.0 like we were keeping it earlier, and GL 3F and this will be white color. And I need you to know that you once set the line width to 3.0, and again this function is called, and if you don't change the line width the second time this function is called, the width will be same. So because this is a state variable and this won't be changed again, to change it yourself using the else block. So now you can call this, run the program, and you'll get your desired output. The boxes at the edges are colored red, so this marks a boundary where the snake should not go. And so this was all for this part of the video. Thanks for watching. Please share and like the video and subscribe to my channel if you feel this was helpful and you want more.